Hello, let us look at some review questions from the homework. Here is the first question. So I want you to look at that first. Here we have to look at the diagram on the right. And EF is congruent to HG or GH. And the other two line segments are congruent as well, as you can see. So first what we need to do is we need to prove that this triangle is congruent to that triangle. Oh, as we have drawn the triangles, what do you see? We realize that the line in the middle is common. So we should be able to prove that these two triangles are congruent by SSS. Let's try to do that then together. So here it is, statement, and then the region. Now first I'm writing down the givens here. Okay. And then second, what else do we realize? Yes. When you look at EG, in fact, that was equal to EG as well. So we can call that as reflexive. Then I think we are already done for part A. We can say these two triangles are congruent by SS postulate. All right. So now let's look at the second one. But those two, when you look at B, angle EGF, I dotted over here already. It's equal to angle GEH. Now, how are they equal to each other? So right now, at this point, right, we're not really distinguishing angles and line segments being congruent versus equal, but we'll just continue in that way for now. And here we have those two angles are equal. Why? The reasoning is because they are the corresponding parts of the congruent triangles. Must be congruent as well. So we can write it as CP, CT, C. All right. Now third, we have to show that those two green marked line EH and FG are parallel. How are we going to do that? Notice that we just proved that two dotted angles are congruent here. Then can you see that we have Z here, or those two dotted angles can be the alternate interior angles. So since they're congruent, then we can simply say HE must be parallel to FG, because if alternate interior angles are congruent, then the line must be parallel. All right. Now, so then, once we have that one, let's continue for part D. Part D, actually, we have to say that the other two line segments are parallel as well. But notice that the dotted angles are not, in this case, are the alternate interior angles. In fact, one that I just marked here, FEG is alternate interior angle. So as EGH. So, then in this case, they are congruent to each other. Why? Because once again they are corresponding parts in previously proven congruent triangles. So I'm going to use CP, CTC once again. Now number 7, then I can say those two line segments are congruent to each other. I mean, not congruent. Sorry, I made a silly mistake. Let me finish writing this one up. I should have said they're parallel. Okay, so here. And then it should have been parallel here. All right, now let's look at the next question here. In triangle ABC, I'm drawing a triangle. A is here, B is here, and C is here. Now, let M be the midpoint. Now, then AB and AC are congruent, and then BM and then CM is congruent as well, as you can see. Now, what we need to do is this. In order for us to say that these two angles are congruent, then ultimately this gray triangle has to be congruent to this orange triangle. once we have done that, then we can say those two angles are congruent to each other. Now, then we realize that AM is common in both triangles. So using that idea, we can write down the statement and reason once again. Now, first, I'm just writing down the givens here. All right. And then that's the given. And second, we get to realize that, okay, BM is congruent or equal to CM. Why? Because a midpoint divides a line segment into two equal parts. So that's what I'm writing here. Now, then what else do we realize? Number 3. Earlier, as we mentioned, AM is congruent to itself by, or equal to itself, by reflexive. Now, then we can say those two triangles, gray and then orange triangles, must be congruent to each other. By, yes, side, side, side. Statement number 5. Since we just proved that those two triangles are congruent, now we can say angle BAM and angle CAM, they are equal to each other. And we can do this one by using the idea of CP, CTC. Now, then we can say the line AM must bisect the angle BAC. Why? Because it ended up creating the two equal angles here. So an angle bisector divides an angle into two equal parts. So with this one, we just finished part A. Now, let's look at part B here. I don't have space, I'm going to just erase this one a little bit. We need to show that those two line segments are perpendicular to each other. That means, wait a minute, we realize that those two dotted angles here, BMA and then CMA, are equal to each other. But at the same time, they're supplementary to each other. That's the idea which we're going to play off. Then first, we're going to say those two angles are congruent. Why? Same reasoning as before, which is through CP, CTC. Now, but next, they also form a line. They're supplementary to each other. They're supplementary. Why? Because they're a linear pair. And they form a line together. Now, then we get to realize that those two must be equal to 90. The reasoning is when the two congruent angles form supplementary angles, then each one must be equal to 90. Don't have space, I'm going to erase a little bit more here. Since they created 90-degree angles, then we know that those two line segments, AM and then BC, must be perpendicular to each other. Simple reasoning is when two lines form 90-degree angles, then the line must be perpendicular. Alrighty, so that's how we can finish number 2. All right, let's go for the next question. So here we need to prove that angle ABD and then angle CBD is congruent, but there was no line segment, so I drew the line segment. And then we have to see that, hey, how can they be equal to each other? They gave us these line segments, the length. That means we can say that those two pairs are equal, and then we realize that BD is reflective, congruent to itself. Hence SSS. So we're going to write that up right now. Once you write that up, as you can see over here, notice that I used the substitution postulate over here. Once you write that up, and then through reflexive, then those two triangles are congruent. Hence, we can say those two angles must be congruent to each other through CP, CTC. All right. Let's move on to the next question. Which two triangles are congruent? Now, so then I see some missing angles. If I know two angles, I can figure out the third angle here. Then knowing that that missing angle is 80, then, oops, those two triangles are congruent. Why? Because side angle, side, angle, side, side, angle, side postulate. All right. Next question. In the triangle ABC, AB is equal to AC. So I'm going to try to draw the picture here so far. That's A, B, and then C, and M is in the middle somewhere. Line AM bisects the angle, so we realize that angle BAM is congruent to angle CAM. Now, the question is, M is the midpoint. How do you prove that M is the midpoint of BC? Then we have to show that BM must be congruent to CM. That's the question mark. So to do that, we're going to show that the orange triangle is congruent to its counterpart. So let's write up the statement and reasons here. All right, first we're going to write down the givens. As we write down the givens, and then let's go back to the earlier one. So here we get angle BAM is congruent to angle CAM. Why? Because a bisector cuts an angle or line segment, either one, into two equal parts. So that's exactly what we're doing here. All right. Now, second thing that which we get to realize is the line segment AM, because it is equal to itself. So by the reflexive property. All right, that's what we end up getting. Now, then we can say those two triangles are congruent. Triangle ABM is congruent to triangle ACM by angle, side angle side. Now, once we have done that, then we can say BM is congruent to CMY. That's what we needed to show that the M is the midpoint. So by CP, CTC, they're congruent to each other. Then number 6, now we can say M is the midpoint. How are we going to show that M is the midpoint? Because it created two equal line segments on the same line, along one line segment. Now, then let's look at the next one. So as we are going, as you're thinking about the next one, it must be a midpoint. How are we going to show that they're perpendicular? Then we need to show them they form 90-degree angle. From the previous question which we have done, you should be able to see that that's possible through showing that these two dotted angles, BMA and then CMA, are congruent to each other. We are doing that right over here. They're congruent to each other by CP, CTC. And then they are what? They're supplementary to each other as well by because they are linear pairs. Then we get to realize that they're each equal to 90 degrees. The reasoning is when two congruent angles are supplementary to each other, then they must be 90 degrees. So that's what we are writing here. Now, soon as you finish this one, then you get to realize that, okay, then they must be perpendicular to each other. Why? Because when two lines form 90-degree angles, then they must be perpendicular. So that's basically what we're writing. All right. All right, so that's basically what we could have done. All right, let's continue. So here, and then we're going to continue here. We need to show that what VZ is equal to. But did you realize that the certain parts are repeating? So for example, 7 and 7, they're equal to each other between those two triangles. And angles are equal to each other. But how about that line segment 8? That's equal to that line segment because 3 and 5 combine to be equal to 8. All right. That means these two triangles are congruent by side, angle, side. So then that side, which is opposite of the marked angle, is the same thing as opposite of the marked angle, which is equal to 3. So therefore 3 must be our answer. Notice that diagram was not drawn to scale. All right, let's look at number 4 here. We need to show that these two triangles are congruent. Now we need to prove that, and then those two lines are parallel. How are you going to do that? By this angle DAC must be congruent to angle BCA. How are you going to show that those two angles are congruent? After proving that two triangles are congruent to each other first. So let's try to write that up, statement and reasoning. All right, same way as before. First, we're going to write down the givens. All right, and just set up the context. Next thing that we mentioned was the AC, which is the reflexive, which was common between those two triangles that which we are looking at. Then we can say those two triangles must be congruent to each other, triangle ABC, and then CDA by SAS. Soon as we prove that those two triangles are congruent, then we can use CP, CTC for these two angles. Angle DAC and angle BCA through CP, CTC. Then we realize that line AD must be parallel to BC. Why? When alternate interior angles are congruent, then we realize that those two lines must be parallel. All right, so there it goes. Next one is this. We need to figure out which two pairs are congruent, and then we need to write them down in particular order. So then as you guys can see, all of them are missing one angle. So we're going to fill up the measure of the last angle. It was in fact 75 for all of them. Now, so we are putting the 75 for each angles. First two are equal to each other in this way. First and the last one were equal to each other. Why? Both of them has 5 was the side, and then 75 and 55 as the angle. So then triangle ABC is congruent to triangle. Now, how are we going to write it? A was the angle that has 75, so then in this case, N is the angle that has 75. And then B was 55, that means M was 55, and the last one was O. Is there any other pair? This one? Oh, 5 is between 50 and 55, same thing for this one as well. So let's try to write them up. By the same ordering for the given measure angles, we can write these two triangles are congruent. And then the method will be ASA reasoning. Alrighty, so that's basically what we have done so far. Let's move on to the next question. So here we have, in the diagram, those two lines are parallel, AB and then CD are parallel. And D is the midpoint of AC. then we need to show that M is the midpoint of BD as well. So let's try to do this one together. That's what we need to prove. So that means, as you can see, dotted angles are vertical angles. And then angle A and then angle C were the alternate interior angles. And then since M was the midpoint, so we can say those AM and then CM are equal to each other. Then I think we're almost done to show that these two triangles are congruent. All right. Then we realize that these two triangles are congruent. So therefore, we can say those two line segments, BM is congruent to DM by CP/CTC. That means M must be the midpoint of BD. In this case, we didn't write down the full two-column proofs, but we just wrote it in this way. And I'm sure you should be able to write them up. Alrighty, good. So then let's move on to the next question. So we need to show that Y angle side, as you can see over here, is okay based upon this one, angle side angle. So I'm gonna first draw two triangles here. Okay, so according to angle side, we have two pairs of the angles that are congruent, and notice side is not between those two angles. It's in fact outside. You see one pair, two pair, and then so we're looking at angle, side. Now, but as soon as you realize there's two angles, then you get to realize the third angle must be congruent as well, as you can see. Oh, wait a minute. That means angle side is given, right? How can they be equal to? You can see that the third angles are equal to each other. So in fact, the angle that's on the other side must be equal to each other. So angle, side angle, that's what we end up getting, because when you know two angles, you get to know the third angle, which is essentially angle side angle here. So that's the reasoning why we can use angle side as the one of the postulates to prove that two triangles are congruent. All right. Now let's look at the last question here. As you can see the givens here, those two line segments are equal to each other and angles are equal to each other. But the thing is, the angle P is reflexive between two triangles, which we like to prove. Now then, so first we're going to write down the statement and reasoning. Okay, I'm going to write down the givens. And after rewriting down the givens, we realized that angle P was equal to itself. It was because of the reflexive property. Alrighty. Now once we have done that, then we can say the two triangles, triangle P QY is congruent to triangle PRX. The reasoning is angle side angle. Alright. But knowing that, it tells us that side PX is congruent to PY through CP/CTC. Now, actually, at this point, I forgot to mention one thing. Let me just write down 3.5. Then QY must be equal to RX by CP/CTC as well. That answers part A. And then we're going to move on to number 5, which try to answer the second question, part B. Now, then this one is possible. QX and then RY are congruent by subtraction postulate. Why? Because whole things were congruent, and we just show that these portions are congruent. That means the remaining portion must be equal to each other. When two red things are equal to each other and orange things are equal to each other, when you subtract them, then remaining, the green portion must be equal to each other, and that's called subtraction postulate. Now, and then angle X and Q and yn are equal to each other. Why? Because they're vertical angles. So once we have done that, then you get to realize something nice here. Then triangle, the two small triangles are congruent to each other. X and Q is congruent to Y and R by angle side. Right? Change the angle here, vertical angle, and another pair of the angles were already given at the do now in the givens, and then by CP/CTC we saw that two sides are equal to each other. Angle, side. All right. Then we are ready to answer part B, which is xn must be equal to yn by CP/CTC, and that's it. I'll see you later.